Hello everyone. This video is brought to you by the Atılım Üniversitesi Open Courseware project for the course Physics 101. The lecture notes are prepared by Associate Professor Dr. Hüseyin Oymak and the video lectures are prepared by Ümit Alkuş. In this video, we are going to solve two problems about uniform circular motion, which is the last subject of chapter 6. Okay then, let's begin. This figure shows a 1 kilogram ball. We have also a vertical post. The ball is attached to the vertical post by strings of length 1.2 meters and 1.3 meters. The ball is set whirling around the post in a horizontal circle with strings being taut. The question is to find the tension in each string if the ball's speed is 6 meters per second. Okay, let's start to solve this problem. At the very beginning, let's write the given quantities in SI units, which are mass of the ball, say m, as 1 kilogram, speed of the ball, say v, is 6 meters per second, and the radius of the horizontal circular motion, say r, which is nothing but the length of the horizontal string, is 1.2 meters. As usual, first we draw the free body diagram of the ball. The ball is represented by a point. Next, we insert an xy coordinate system whose origin at this point. The gravitational force acting on the ball is a downward force which is equal to m times vector g. The tension forces on the ball, say T1 and T2, are drawn like these. And angle theta goes here. Then it is convenient to decompose vector T1 onto the x and y axis like this. In this problem, theta is not given explicitly, but it can be found easily by calculating the third side of this right triangle as 0.5 meters by the Pythagorean theorem. Okay, that's all about free body diagram. Let's calculate T1 and T2. In this problem, you see that there is no motion in the vertical direction. So, net force is 0 in the y-axis. So that Fnet equals T1 times sin theta minus m times g. Then T1 times sin theta equals m times g. Dividing both sides by sin theta, we find an expression for T1 as T1 equals m times g over sin theta. Putting the related numerical values into this formula, we obtain that T1 equals 1 kilogram times 9.80 meters per second squared divided by 0.5 meters over 1.3 meters by this right triangle. And the result is 25.480 newtons, which is approximately 25.5 newtons. Again, Remember that the intermediate result is in 5 digits and the final result is in 3 digits. Now we can find tension T2 as follows. Since there is a uniform circular motion or centripetal motion in the horizontal plane, then we can write the Newton's second law for this motion as F net equals m times AR. The net force of our concern is hence the horizontal net force in the x-axis, which is calculated to be T2 plus T1 times cosine theta. And radial acceleration denoted by AR is found by the formula v squared over r. Thus, the expression for T2 is found as T2 equals m times v squared over r minus T1 times cosine theta. Now, substitute the corresponding numerical figures into this formula to get 1 kilogram times 6 meters per second squared divided by 1.2 meters minus 25.480 newtons times, from the right triangle, cosine theta is calculated as 1.2 meters over 1.3 meters, which results in 6.48 newtons. Great! We have found tensions in each string. Then, let's move on to the second problem.